Welcome. Today we're going to talk more about probability. Now, when it comes to probability, the thing I want to emphasize is that we are talking about events that can happen and what's the probability of a certain number of those events happening versus other events. So we're going to talk a lot again about a dice as an example. On the dice, we have those 6 possible outcomes. We could roll a 1 or a 2 or a 3 or a 4 or a 5 or a 6 or any of those numbers up to 6, right? So there's 6 possible outcomes. That's our sample space. And then we talk about what is the probability of 1 or 2 or 3 of those things happening. For instance, we could say, what's the probability of rolling a 2? Well, the probability of rolling a 2, there's only one side that has a 2 on it, so it'd be 1 out of the 6 events, so you'd have a probability of 1 out of a 6. If you wanted the probability of an even number would be a 2, a 4, or a 6, so there's 3 out of the 6 events that are successful outcomes, so you'd have a 3 out of a 6, which would reduce to 1/2 or a 50% chance of rolling an even. Today's lesson, we're going to be talking more about these terminology over here, like what's the probability of something not happening? So, and again, this would be the way it'd be written. If I wanted the probability of not rolling a 2, then you come over here and you think about, okay, what are all the outcomes that are not 2s? Well, I have a 1, a 3, a 4, a 5, or a 6. Or I have 5 possible outcomes that are not a 2. So I have 5 out of the total 6 outcomes that are not a 2. So the not probability is pretty straightforward. If I do want the probability of not an even, well, how many of these numbers are not even? Well, 1, 2, 3 are not even, so you'd have the probability of 3 out of the 6, or again, 3 out of 6 reduces to 1/2 or a 50% probability of not an even. So the word not should be pretty straightforward. The next thing I want to talk about is what we mean by mutually exclusive. A lot of times mutually exclusive comes about by they're using the words and versus the words or. So again, let's say I wanted the probability of 2 or an odd. 2 or an odd. Well, to roll a 2 versus rolling an odd, they're called mutually exclusive. The reason they're mutually exclusive is because a 2 is not an odd, and an odd number can't be 2. So it's either one or the other. It's mutually exclusive. And we can do the probability of a 2 or an odd. Well, there's one chance of getting a 2. There's 1, 2, 3 chance of getting an odd. And we add those probabilities together as long as it's mutually exclusive. Meaning you can't do the 2 at the same time. And so 1 chance of getting a 2, 3 chance of getting a odd, 1 plus 3 is 4 out of 6, or a 2/3 chance of rolling a 2 or an odd, right? That's the word or. If they'd used the word and, the probability would be 0, because you can't roll a 2 and an odd. 2 is an odd. So if you rolled a 2, it wouldn't be odd. If you rolled an odd number, it wouldn't be 2. So it's impossible to roll a 2 and an odd, so that probability would be 0. So again, that's kind of what mutually exclusive means, is that you can't do both at the same time. But there is what's called overlapping events. If I wanted to do the probability of a 2 or an even, 2 is even, and an even might be 2. So be careful when you calculate this probability, as you don't want to double count the 2. You don't want to say, all right, I have a 1 chance in rolling a 2, and then to roll an even, I have a 1, 2, 3 chance. So I add the 1 to the 3, that'd be 4. That would be incorrect, because you've double counted the 2 that is both even and odd, or sorry, even and 2. 2 is both the 2 and the even. So we don't want to double count when we have overlapping events. So you'd say, all right, there's a 1 chance in rolling the 2, and then there's 2 other numbers that are even, or there's a total of 3 out of 6 of rolling a 2 or an even, or a 1/2 or 50% probability of rolling an even or and 2 or an even. So be careful with overlapping that you don't double count some of those numbers. The next thing I want to talk about is experimental probability. With dice, we're using what's called theoretical probability. Theoretically, we have the exact same chance of landing on each side of the dice. In real life, a lot of times we don't have a theoretical probability. What we have is called experimental probability. Like, for instance, if I'm at a grocery store and I'm watching people walk in the door, I might want to know what's the probability that the next person might be a female. Well, you would might say, okay, well, that's 50-50, because it's either the next person might be either male or might be female. But that wouldn't necessarily be true, because depending on the time of day, depending on who goes shopping, it might be different. So what we might want to do is an experimental probability. For instance, let's say we had kept track of the last 10 people that had come into the store. And of the last 10, so there was a total of 10 people that we kept track of. Of the last 10 people that came in the store, 8 were female and 2 were male. So if 8 were female and 2 were male, experimentally, the probability that the next person's going to be a female, well, we have 8 out of the total 10 that came in, we have a probability of 4/5 chance that the next person will be a female from experimental information. So that's what's experimental. We don't necessarily just use, well, okay, there's 50-50 chance that it's male or female. No, we look at what's happened in the past and we use that to kind of predict what's going to happen in the future. So today's homework, again, I'm going to go now to here, is the first one is just probability of opposites, which is that not mutually exclusive and overlapping. That one should be pretty simple. If I look at that very quickly, if I go into that, we'll do just a couple here. It's going to say stuff like, what is the probability of rolling an odd or an even? Now, what's nice is now we can actually get a full 100%, because to roll an odd or an even, well, every number on there is either odd or even, so that's 100%. So we can actually have 100% of something happening. Here, what's the probability of not a tails? Well, again, theoretically, we can either roll a heads or a tails. So how many outcomes are not a tails? Well, just the heads. So we have a 1 out of 2 or a 1/2 probability. We're asking what not. Now here's what's the probability of a 6 or less than a 7. Now be careful. Less than a 7. This is our overlapping probability. There's a 1 chance we roll a number that's a 6, and that 6 is also less than 7, so don't double count it. There are no other numbers less than 7, so 6 is the only possible outcome that works. It's 1 out of 3. Don't do accidentally 2 out of 3 by double counting the 6 by saying, well, 6 is less than 7 as well. You don't double count it. Okay, what's the probability of not even? Well, how many numbers are there on the 6-sided dice? There's 6. How many of them are not even? There's 3. So 3 out of 6, or a 50% chance that we're not going to get an even. So here's an even or less than 5. So again, there's only one number that's less than 5, and that number happens to be even. So there's only a 1 chance of getting an even or less than 5. 1 chance out of 4 is a 25%. So hopefully these will go pretty quickly. Oh, it's 50%. Probability of even or less than 5. Why would that be 50%? Even or less than 5. Oh, sorry, even. There's another number that's not even. Why was I? Okay, so be very careful that you read carefully. I want the probability of an even or less than 5. I didn't include 6 in my even numbers, and 6 is even. So be very, very careful. 4 and 6 are even, so there's 2 chances of getting an even number. There's 1 chance of being less than 5, but that 1 is a even, so don't double count it. So don't do 3 out of 4. There's just those 2 chances. You either roll the 4, which happens to be less than 5, or it's even, or we roll the 6. So that would be 50% chance. I'm glad I did one wrong, so don't feel bad if you don't read carefully. Make sure you read very, very carefully as we do these. I got this. Hopefully you got this. We want 3 or less than 3. Well, there's only 2 numbers that are less than 3. That's 1 and 2. Plus there's 3. So I'm going to be very careful here. There's the 1 and the 2, and then there's the 3. Again, there's 3 possible outcomes out of the 6. So again, that's going to be 50% because there's 3 possible successes. Right? The other one I want to talk about before we run it, I don't want to keep this too long, is that experimental probability. Experimental probability is just that, what I talked about like at the grocery store. They're going to give you an experiment. It says, of the last 6 trains to pull into Oakland Station, 4 were full. What is the experimental probability the next train pull in will be full? Now, again, you think, well, they're either full or they're not. Maybe that's a 50-50 chance. But no, we're going to look at the experimental. There was a total of 6 trains they've kept track of. Of those 6, 4 were full. So what you would do is you would say 4 out of the 6, and then you would reduce that to 2 out of 3. So again, 4 out of 6, I'm going to actually maybe do, so I can show something here. So you can see that we do the 4 out of the 6 total, we reduce that to 2 out of 3. So over here, write your answer as a fraction. 2 out of 3, I make sure I reduced it and hit submit, and I get good work. Lucky flips a weighted coin. What weighted means is it's not a fair coin. It's not going to be 50-50. And of the 18 times he flipped it, 8 were tails, which is less than half. So it looks like you're more likely to get a heads. So the question is, what is the experimental probability the next flip will come up? Tails. Well, if experimentally he flipped 8 tails out of a total of 18 flips, then if we reduce that, we get what? 4 out of 9, which is not quite 50%. So I come over here and I type in 4 out of 9 as my reduced fraction. That's the probability of flipping tails. Now be very careful. I want to emphasize that if we get to one that has a percentage, that make sure you round to the nearest, I think it's integer, our nearest 1 decimal place. And it's probably not going to give me one. It keeps asking it for a fraction or as a whole number. But realize that, here's a nice one. I should look at this one, and then we'll call it good for today. It says, a choir teacher took the students who have enrolled in her class so far and classified them by which parts they sing. So 6 sing tenor, 6 sing sopranos, and 16 sing altos. What is the experimental probability that the next student to join will be a tenor? So again, we don't necessarily think it's a 1 in 3 chance because it looks like a lot more people like to be altos. So what we need to do is make sure we do the total. So what's the total number of people in the band at the moment? Well, 16 plus 6 is 22, plus 6 more is 28. So there's a total of 28 people in the choir, and of those 20, how many are tenor? Only 6 are tenor. So the probability that the next person to join is going to kind of probably be this probability here. So we reduce that to 3 out of 14. There's a 3 out of 14 chance that the next person will be or will want to be a tenor. We did good work. So if you have any questions on this, please do contact me via email or log on at 1 o'clock, and I will help you be able to do this probability.